Hello, my name is Sam. I am a maths tutor and an A-level maths student, and this is a video introduction to integrating, specifically integrating x to the power of n. This is an AS level topic which we're going to look at in this video, but the integration topic as a whole carries on into year 13 and does get much harder if you're studying the normal A-level. So let's get straight into it. You can see an equation up on the screen. That symbol there is integral, so this is integral of x, and dx there means with respect to x. So we are looking at integrating the function x with respect to x. If you were going to just write this out, you might just write integral of x, or if you're going to be more proper, you can do the integral of x dx. Sometimes this might be in brackets as well. So I'm going to assume here that you have a somewhat basic knowledge of differentiation. Normally people learn that first and then they move on into integration, and so I'm going to assume you already know the process of differentiation, where if you were to differentiate x squared, then you would multiply by the power, so you would get 2x, and then you would drop the power by 1, so this becomes 2 minus 1, which is just 2x. I'm going to assume that you already know how to do that, and integration will not be so tricky. So what is integration first? Well, differentiation finds the gradient function for a curve. So say you have the curve x squared, then differentiating x squared will return 2x. That is the function that will tell you the gradient of that curve at any point on that curve. Integrating is the opposite process, but it gives something slightly different. So if I were to integrate x, it would give me the integral for x, which will tell me the area underneath the curve x, so between x and the x-axis, between a given interval. Now, there is no interval in this question. We're just going to look at the process and how to do it first, but there is a question later on in the video that has an interval, and we will look at actually finding the area. But integration will give us that area underneath the curve. So let's have a look at how we actually do that. So I'm going to clear this from the screen. So we're going to start with the integral of x in terms of dx. Now in differentiation, you would multiply by the power, so 2x, and then you would drop the power by 1. Integration is the opposite by that. We are going to raise the power by 1, so this is going to be 2 plus 1, and we are going to divide the coefficient of x squared. So the coefficient of x squared is 1, it's just not written. We're going to divide that 1 by the new power, 2 plus 1. So this would be equal to a third x cubed. Okay, so if you were going to do the same thing for x cubed and you wanted to integrate x cubed, you would add 1 to the power, so this would become x to the 4, and then you're going to divide by this power, so it would be 1 over 4. So for our question, where we are just integrating x, we're going to add 1 to our power of x, so this is going to become an x squared, and we're going to divide by our new power. So the previous coefficient of x was 1, we are now going to have a half x squared. Then we need to add c. So c is our constant of integration. Basically where this comes from is if you were to differentiate 2x plus 1, this would give you just 2. But the 1 has disappeared. If you're going to integrate this 2, it would become 2x. The reason why you need the c is because if you integrate a function, you should get, if you differentiate a function and then integrate it, you should get the original function. And this c, in this case, is the 1, but you don't always know that. And so we need to add a c in here, always, because the differential of a function which gave us x may have had a c in its equation. And so we do need that, and that's very useful when studying differential equations as well. This is an absolute must-have. You will drop marks in the exam if you do not have this c. And this c only occurs in a case where there are no limits on this integral. So this integral has nothing up here, but we may have numbers. I've just written b and a there, just as an example, x dx, and I'll show you how we solve something like that in a few minutes. So that is the answer to this integral x dx. And I've got the graph here of x. Now, if we're going to plot the graph of x squared dx, of the half x squared dx, then you would get your normal curve, but it would just be half of the magnitude. You probably won't be asked to draw an integral. I highly doubt they'd want you to do that, but just know that that is, you would then, well, I'm sure you know how to plot that, but then the y-intercept would have to be c. You wouldn't be able to say definitively where on the y-axis this actually crosses, as it will cross at the coordinate c, which is why it's necessary to have the c. Okay, so let's move on to our next example. Now this one looks much harder, but it follows the exact same process as the previous one. So we are still just integrating our x to our power of n term. We have no bounds, so this is just the same as what we were doing before. You're just doing it more times. Now, you may be confused by the fact that this is in a bracket. So where we have all of this in one bracket, it does not mean we have to treat this any differently to previously. We can treat all of these separately as their own thing. So while in this case we have no bounds, so we are able to do this. You will not always be able to do this, but we can say the integral of 2 to x cubed plus the integral of 6x squared plus the integral of minus 3, and you would need to put dx in front of all of these, which unfortunately I forgot to do. But yes, this is the same thing as if this was b to a, then you would need to make sure that all of these would be to a as well. But you can split that up. You don't need to write that step though. You can just consider all of these individually. You can just go, okay, well, I'll integrate 2x cubed, and then I'll integrate 6x squared, and then I'll integrate minus 3. So how do we do this? Well, 2x cubed, we're going to raise our power of x by 1, so this is going to become x to the 4, and then we are going to divide our coefficient of x cubed by our new power, so this becomes 2 over 4 x to the 4. We're then going to add the integral of 6x squared, so this 2 is going to be raised to a 3, as we need to raise our power by 1, and then we are going to divide our 6 by our new power, so this is going to become 6 over 3x cubed. We are then going to add the integral of minus 3 dx. Now, because of this dx, we are integrating minus 3 with respect to x. Now, a good way to try and understand this process is to think of what happens if you differentiate minus 3x. If you're just going to differentiate minus 3x, the answer that you're going to get is minus 3. The x completely disappears. And so if you are integrating just a constant term, then all you need to do is add on, well, not add on, you're multiplying on the term that you're integrating. So in this case, it's an x. If this was dt or dy or dA, then you would add that variable on to the end of the number. We then need to add our plus c, so I'm going to just remove this. We then need to add our plus c onto the end of this equation. It's very necessary, you must always remember to do that. And we can simplify this expression. So 2 over 4 is just going to be a half x to the 4 plus 2x cubed minus 3x plus c, and that will be your answer. And this was for where there are no bounds here, so I was just writing this down for an example, but this is where there is no bounds on this integral, and so we must have the plus c, and yeah, everything is as we expect. And this function, then, if you were to put in some values of x, which we're going to see in a minute, will give you the area under this curve, well, between this curve and x, for a given interval. So let's look at how to do that in this example. So here we have the integral of x squared plus 2x dx, and this time we have a 2 and a 0 on our integral. So we have 2, 0, x squared plus 2x dx. Now, the integration is going to be the same, but there's going to be more steps on the end here because we have this 2 and the 0 on our integral. I've also got the curve, x squared plus 2x is going to be useful to explain what this integral actually means. So previously, if we were going to integrate this, it gives you a function which will tell you the area underneath the graph between a given interval. but what does that actually mean? Like, there's only one value of x that you can put in. Well, if this is 2, then we're going to draw a line on 2 here, and then 0 is here. And so this integral, when we solve it, will tell us this area here between the curve and the x-axis. It's going to tell us all of that area, and it is going to be the exact area as well. It's going to be completely accurate and not an approximation. If, say, this was the integral between 0 and -2, it would tell us the area between the bottom of this curve and x, so it would be that area there between the curve. And that area would come out as negative, and so you would have to put a negative sign in front of that integral to make sure that it was of the correct magnitude. Okay, so let's work on solving this. So the integration here is going to be the same. Integrating x squared and 2x squared is going to be the same. So we're going to add 1 to the power to make this an x cubed, and then we are going to divide by our new power, so a third x cubed. We're then going to integrate 2x squared, so we're going to add 1 to the power of this x, which is going to make it x squared, and then divide by our new power. 2 over 2 is 1. However, now to deal with these bounds, we're going to put in some square brackets and write our 2 and our 0 here, just to show that this is the answer to our integral, and now we want to find out the answer to this equation between these two bounds, 2 and 0. And to do that, we're going to substitute 2 into this equation, and then we are going to subtract this equation where we have substituted in 0 for our x term. So let's do that. I like to use square brackets here. Sometimes there is something multiplied by this integral, which there isn't in this case, but I like to use square brackets in case you want to put a constant term before the brackets. And I'm going to use another set of brackets to do a third of 2 cubed plus 2 squared, close brackets, subtract a third of 0 cubed plus 0 squared. That is a 1 times 0 squared. And then close brackets. Now to calculate this, we're going to do a third of 2 cubed, which is a third of 8 plus 4. Sorry, that's a really wonky looking 8. And there's going to be minus 0 cubed is 0, and 0 squared is 0, so this is just going to be subtract 0. So our answer is going to be 8 over 3 plus 4, which is 8 over 3 plus 12 over 3, which is 20 over 3. And that is our exact answer, and you do not need a plus c on the end of this. It's really important to note that the answer to this integral, what's inside here, does not need the plus c. When you are calculating the area and you are substituting in a value, you do not need to include the constant of integration. That is only for a definite integral where you are trying to find a function which is the integral of an original function. So this c here is very much necessary, and you will lose a mark in an exam if you do not have it. However, down here, our answer for the area is just 20 over 3, so it is not necessary to have the plus c, nor is it necessary to have the plus c in here in these square brackets. Okay, well, I hope that video was helpful. If you would like to suggest any videos, please do write something in the comments, and thank you very much for watching.